A ketone, much like the aldehydes, have a carbonyl group present in the hydrocarbon chain. The difference from the aldehyde is that the ketone carbonyl group takes place in the middle. So, not at the end. Because that double bond to an oxygen is in the middle of the hydrocarbon chain, the properties are different, and therefore we will give it a different name. In this case, we will use the root name as usual, and then end with the suffix -one. Now again, I like to memorize this, much like the alcohol name and the aldehyde name, by ending in -one, which is also the end of the family. To name these, you will again choose the longest continuous hydrocarbon chain. So 1, 2, 3, 4, 5, 6, 7. 7 is the longest, and therefore I will start with the root hept. Now in this case, I do need to number so that the interesting part of the molecule, our double bond to an oxygen, the carbonyl group, is the lowest possible number. So there are two ways I can number this. I can go 1, 2, 3, 4, 5, or I can go in the reverse direction, 1, 2, 3. As 3 is the lower number, we will number this chain from right to left. To finish the suffix, I will indicate the location of the double bond to the oxygen using a number in the middle of the suffix. So heptan dash 3 dash -one tells me there's a double bond to an oxygen on the third carbon. Now, like our other examples, we will need to name the side chain. In this case, it's a 1-carbon chain, and therefore a methyl group. And of course, we will have to indicate the carbon as being number 5. In this example over here, we can do the same thing. Name the longest continuous chain that will involve the carbon with the double bond to the oxygen, as that is the interesting thing. We know that mid-chain means it's a ketone, and therefore will end in -one. So we can start with -one. I'm going to count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6, 7, 8. It seems that no matter where I go, I get a carbon chain of 8, which is oct. I know I'm going to have an, so octan-one, but this time, again, I need to indicate what number. So 1, 2, 3, 4, or if I go in the opposite direction, 1, 2, 3, 4, 5. So I'm going to number here with number 1 and indicate that it is on the 4th carbon, so it's octan-4-one. Of course, we can't forget our side chains here. That is a 2-carbon side chain, so that is ethyl. And to number it, 1, 2, 3, 4, 5, 6. Now, of course, not to be outdone, ketones can also have a cyclic structure. The ketone here will be cyclo, because it's in a circle. 1, 2, 3, 4. Bute, and then of course we're just going to add -one because it is in the middle, but the number 1 preferred spot. On that note, is it possible then to have a cyclic aldehyde? We didn't show an example in the previous tutorial because that is not possible. An aldehyde must be at the end. Therefore, any cyclic structure must be a ketone. And there you have it, how to name ketones.